You ever been really excited for a new app? You download it and it's just clunky, confusing, or not at all what you were promised? Yeah, it happens all the time. Today, we're going to pull back the curtain on how professional software gets made to figure out why that happens and, more importantly, how the pros build software that actually works. Every single time. Let's dive in. So it all starts with this really classic problem, the gap between what a user pictures in their head and what they actually end up getting. And this isn't a small thing. It's a challenge that literally every software project faces, whether it's a simple little game on your phone or the massive, complex systems that run our banks. And that really is the million-dollar question, isn't it? We've all used software that feels like it was designed by someone who's never actually met a human being. So why does this disconnect happen so often? Is it just a bunch of bad coding? Or is there something, deeper going on? This right here, this visual just captures the problem perfectly. On the left, you've got this brilliant, clear idea from the customer. But on the right, that's what sometimes gets delivered, a confusing mess. The source material is clear that this isn't usually from one single mistake. It's more like a chain of tiny misunderstandings that just snowball into a big, failed project. And here it is, the root cause. It's usually not about the programming skills. The breakdown almost always happens right at the very beginning. If you don't have a totally crystal clear, shared understanding of what you're trying to build, you're pretty much setting yourself up for failure before a single line of code is ever written. So how do we fix this? Well, with a blueprint. I mean, you would never, ever build a house without one, right? And software is absolutely no different. In the world of software engineering, this whole blueprinting process is called requirement analysis. It's the disciplined, careful process of turning a vague idea into a rock-solid plan. This whole process really breaks down into three main stages. First, you gather up all the needs and wants from everybody involved, the clients, the users, everyone. Then, you analyze those requirements to make sure they're clear, they're actually possible to do, and that they don't contradict each other. And finally, and this is so crucial, you document everything. And this documentation isn't just a bunch of notes, it becomes the official contract for the entire project. This final document becomes what's known as a Software Requirements Specification, or SRS for short. You can think of it as the project's constitution. It's this formal report that everyone signs off on. It's not just a guide, it is the binding contract that defines exactly what a successful project looks like. All right, so once you have that blueprint, that SRS, you can finally start designing the solution. This is the stage where you shift from the what the software needs to do to the how it's actually going to do it. And a good design isn't just about making things look pretty. It's about being smart, stable, and solid from the inside out. According to our source material, any really great design has four essential qualities. First, it just has to be correct. It has to do what it says it's going to do. Simple enough. Second, it needs to be understandable, so that other developers can jump in and work on it later without pulling their hair out. It also has to be efficient, so it doesn't hog your computer's memory or battery. And finally, and this one is so important, it has to be maintainable, because software is never really done. It's always evolving with updates, bug fixes, and new features. But how do you actually achieve that all-important maintainability? Well, designers focus on two core ideas that sound super technical but are surprisingly simple: coupling and cohesion. I'm telling you, getting these two concepts right is the secret weapon for building software that can evolve and last for years to come. Let's start with this quote from the source, because it's the perfect way in. A good design is the one that has low coupling. Okay, what on earth does that even mean? Well, it's all about how interconnected the different parts or modules of your software are to each other. Let's put these side by side to make it super clear. Coupling is all about the connections between different modules, and the goal here is to make those connections as loose and minimal as possible. Cohesion, on the other hand, is about how well things are organized within a single module. And there, you want that organization to be super tight and focused. So the mantra is low coupling, high cohesion. Let me give you an analogy. Low coupling is like having a well-built house. You can decide to totally renovate your kitchen, rip out the cabinets, get a new sink, whatever, without having to worry that the bedroom upstairs is going to collapse. The different parts of the house are independent. A change in one area doesn't cause a disaster somewhere else. That's exactly what you want in your software.
And high cohesion just continues that same analogy. It means your kitchen module has all the kitchen things: a stove, a fridge, pots and pans. It doesn't have a lawnmower or a box of wrenches randomly thrown in there. Every single thing inside that module is strongly related and serves one clear purpose: cooking. This focus makes each part of your code so much easier to understand and manage.
So let's just recap. We've gone all the way from a fuzzy idea to a concrete blueprint, and then we've drilled down into the core principles of what makes a design really strong and resilient. It's all of this upfront thinking that truly separates the software that works beautifully from the software that just drives you crazy. So, the single biggest takeaway is this: great software isn't about one genius programmer working in a dark room. It's about one clear, well documented blueprint. A plan built on those smart design principles, like low coupling and high cohesion, is really the only reliable way to prevent the final product from becoming a tangled mess. So I'll leave you with this little challenge. The next time you're using an app that just feels right, it's intuitive, it's stable, it's a pleasure to use, just remember it is not an accident. It's the result of this incredible, invisible architecture built on a solid plan. Now that you know about the blueprint, what can you see working perfectly under the surface that you couldn't see before?